Hey everybody, it's Brandon Hart, the EcoStruder. I am here with something a little different, something that we don't normally do, and that is I just wanted to show an overview, a time lapse of what it's like to build a Big-60 V3 3D printer. So you've seen on the channel the Big-60 V2. We did a pretty extensive dive into putting the machine together, doing a review, seeing how it is after a year, all that kind of stuff. But, and I don't want to get that deep into doing the V3, but I did want to give you an idea of kind of what the process looks like and how it all goes together, etc. So I just went ahead and set up some GoPros and started filming the process. So there's not going to be a whole lot of explanation here besides the voiceover that you're getting from me on the video. So with that said, let's jump into the build Big-60 time-lapse video. So here we are, just pulling out the parts and organizing things. This is a surprisingly important step. There are a lot of parts in these machines, and so getting everything lined up, getting everything ready to go is pretty important. Okay, first thing you start with on a Big-60 is you build the frame. So I often get asked whether you can take some of these machines partially apart in order to be able to get them through doorways and things like that. And as you can see, when you build the frame first, you really can't take the machine apart to make it much smaller. So everything starts from the frame. Here you can see we've got the 4 different corners that have been built. And this is one of the nice things about the V3 machine is you actually have the ability to have individual bed corners assembled, so it's not a big frame. There's also, by the way, a ball screw per corner. So that's a pretty nice thing. Here we're putting together the linear rails. These are the high-wind linear rails. I'm using 3D printed guides to make sure that the spacing is correct. And basically, these rails are a big improvement over V2 as well. These are bigger, beefier rails that provide better precision for X and Y movement. There's also an option to get these same rails for the Z axis, which helps improve the stability of the bed as it goes up and down. You can see I'm consulting the directions here as I go. The directions have actually been greatly improved over the version 2. I think I even made a comment about that a couple times in the build video for the version 2, where some of the instructions just kind of weren't very detailed toward the end especially, or there weren't very good ways to kind of explore it further. You know, we got to dive in and zoom in on pictures and things like that. They've vastly improved the build instructions on V3. All right, so here I am getting ready to put the I think it's technically considered the Y axis, although that's the same carriage that is used for moving back and forth in X as well. So here we are fitting that. And there we have all 3 axes that are fully in place. They exist at least. A lot of tweaking, a lot of dialing it in to actually make these things work properly. But at least we've actually got motion in all 3 dimensions now. So again, this part takes quite a while to tweak and dial it in. I'm going to use those same 3D printed calibration jigs, as you can see right there, to make sure that the Y-axis is completely parallel to the frame, and that makes sure that everything is square as we start to tighten everything up and add movement to it. Okay, so the shot just changed, and I want to tell you why. So I had a previous GoPro. It was a GoPro Hero 7, I think, black, and it was a nice one, but it fell. And apparently a fall from this height onto that concrete floor is not something that a GoPro can survive. So we're now using a GoPro Silver, and I can't really change the aspect ratio, so little fisheye action going on here. But yeah, so what you can see going on in the video is we're putting belts on, and we're putting belts on the X-axis and on the Y-axis. One of the nice things, again, it's an improvement of V3 over V2, is that you can sort of see them in the back of the video there. I'm working on one right now. Those are the X-axis motors. There is no longer a big rod that connects one single motor to drive both sides of the X-axis. There's just one motor per side, so one motor per belt, and it moves the carriage at the end of each one of those axes. So here we're actually attaching the rails for the bed. So we're attaching them to the four corners. This is one of the nice things about this particular design, because of the individual corners are separate. They're tied together with the bed itself. And so we're just using some 2020 extrusions here, fastening them to the corners, fastening them loosely, because we're then going to put some additional brackets on there to tighten everything in, draw it in, make it square, make it tight. And so that's an important thing to consider. If you tighten them down right away, you could be tightening them down in the wrong position. So we don't want that. Okay. And again, just trying to be real careful about this. Get everything where your all four corners are roughly the same height. Okay, we've got the bed on. Now we're putting the build plate onto the bed. This is a tricky thing because that is a heavy piece of metal. That is a big, thick piece of Mic 6 Alcoa aluminum plate. So it's a tricky one. Yep, phone calls never stop. So those keep coming in. Yep, so tightening the bed down to the bed frame, and there we go, getting those in there. So the interesting thing about doing this is you actually don't want to tighten the aluminum plate down to the bed frame very hard, because if you do that, the aluminum, while it is Mic 6, it doesn't expand as much as, Alcoa, it doesn't expand as much as a typical aluminum plate does. It does expand somewhat when it gets hot. So you want to account for that and allow it to expand and contract. Otherwise, you're going to cause unnecessary warping. All right, not the most fun part, where I actually run all the cables through the cable chains, but it is a necessary part, and it's part of having a nice machine here with good cable management. So there are two different cable chains, one for X, one for Y, and you have to line these up. Now, when I put this together, you notice I just lowered that guide rail there. That's a kind of an interesting part in the instructions. The initial thought on that was that the rail was in the wrong place, but when you go to put the enclosure on, there's a very specific place where that rail needs to be on the back side. So, take that as you will. You see I kind of raise it up there a little bit to accommodate the flex in that chain, so that it can move back and forth properly. This is a tedious part where it's just a matter of getting all of the cables run in there. You want them to run side by side and not overlap with each other, because that'll restrict the movement of the wires in the cable chain. You also have to open and close these things a few times, because sometimes you add additional wires in there, or some of them unintentionally get overlapped with each other. And so this does take quite a while. Be patient. Once you get everything in there, now you also have to size the ends of the cables. So those need to be the right length, so that when you go to put the print head on, all the wires terminate in just the right place, so you don't have a bunch of extra wires hanging out. But if you do it right, this is actually kind of an enjoyable process, because you can end up seeing a nice, pretty, and I don't know, to me this is fun. You can see a nice cable management of all the wires kind of running right next to each other, coming out at the right spots. You may have to loosen the cable glands on the electronics box and pull the wires up into it, as you can see I'm doing there, to make sure that they all come out at the same length and the correct length for the print head. Once you got them all in there, use your handy dandy zip ties to secure them in place so they don't move around on you after you've got them all to the right length. And then it's just a matter of getting everything plugged in. So we need to plug in the motors, plug in the print head when we get to that step, plug in everything to the board, make sure everything's where it needs to be. Here I'm running the wires for the Z-axis motors. There are 4 of them, but they're all run off of the same stepper. So basically what's going on here is we've got one big wire, one big cable that runs all 4 of the steppers. And so those steppers all need to go back, and they all need to hide inside of the 4040 profile. And yes, my floors are dirty, and so I will be as well as a part of this process, but hey, that's part of the fun. So all the wires are getting run for the steppers. Here I'm running a wire for the X-axis motors. Again, we turn the machine around here, so it's actually looking from the front. Time to put on the panels on the front so you can actually identify that this is the front now. It's got a front panel on it. It's got the name Modix on it. And you can see in the upper left-hand corner there, that's where we're going to put the screen and where the cables need to run in through as well. This bottom panel is going to come on and off of the machine a few times throughout the course of the build because we need to put the heated bed controller in there. And then later on, we're also going to put a panel underneath all of the bed controller. And so you need to take everything off to be able to get that new panel back in. So go ahead and put it together so that everything is where it needs to be, but just know that it's not going to be the last time that you put that on there. All right, so with that done, it is now time to move on to putting the screen on the machine. So the screen itself goes into this red box, and you want to be careful with it because the Duet does have a touch screen on it. So the V3 machines all come equipped with these touch screens. And if you tighten the screws down on the brackets that hold the touchscreen in, the touchscreen becomes non-responsive, or it thinks that you're touching on the edge of the screen where it's pressing up against the frame, even though that's not actually what you're meant to do. So it's something to keep in mind. You want to tighten it down just enough to hold it in place, but not so much that the screen itself is actually pushing against the bezel. All right, so with that done, we are now moving on to running the rest of the wires and attaching the print head to the tool head, to the gantry there, and then going to connect all of the wires that we previously ran through the cable chains so that they all came out at the right length so that we can now connect them into that print head. And here's the part where the business end is being attached to the machine. So this is kind of starts to feel like you've got a real 3D printer at this point. But in this case, the customer wanted to have two different print heads. So they had a primary and a secondary print head. And so there's some adjustment that is required to raise and lower that second print head to get it to be the same height as the primary. So that's what you saw me doing there. Here we are assembling the filament detection sensors. Again, this is a dual extruder machine, so there will be two of them. Putting together the spool holders. Those aren't going to go on the machine quite yet because this machine still needs an enclosure on it. But we did go ahead and pre-assemble those parts so that we can just put it on real easily once the enclosure is ready to go. Yep, more wiring. Not a lot to say about that. Lots of wires, lots of stuff to attach. I will say one nice thing about this is that everything is labeled and terminated. So you don't have to crimp wires, you don't have to cut wires, you don't have to solder wires. You just have to figure out, that the two different connectors are supposed to go, attached to each other. The connectors are all different from each other too. So while it is possible to make a mistake and plug the wrong thing in, it's unlikely since there are small connectors and 3-pin connectors and 4-pin connectors and terminals and stuff like that to make it very clear that, the motor, the extruder motor connector does not get plugged into the temperature sensor or something silly like that. All right, so here we're doing a little bit more wiring, getting everything set up on the controller box. Putting the cover on, making sure everything is properly connected there. All the wires are running in the right place. Again, we want it to not only function, but also look nice. So we don't want any extra wires kind of dangling out where they shouldn't be. And we want all the cable management to look good. As much as possible, we want the wires to be concealed within the frame itself. So there shouldn't be a bunch of extra wires sort of hanging or drooping as they go from the front to back or side to side. All right, so here I'm plugging in the power cable. It's kind of an exciting point. You can see I plugged the machine in and didn't have enough outlets or enough room, So, hey, look at that. We got the screen turned on. This machine is alive. It's not totally functional quite yet, but it is alive. So here I am setting it up for Wi-Fi. I'm figuring out its IP address from my router so that I can get it all connected. Tapping in the password multiple times because I had some trouble getting this connected properly. So here I turned it back off again because it wasn't quite working. Came back the next day, and in this case I ended up actually plugging in a USB cable to get it working, and then working on the bed heater controller to get that going, because there are some values that you need to get set up in the machine in order to be able to make it work. The wooden crates then are padded, and inside of the padded wooden crate is a cardboard box. The cardboard box has all the different panels inside of it. In this case, these are what are known as ACP. So that's basically aluminum sheet metal with some plastic in the middle. The nice thing about those is they're not going to crack or break like the acrylic from V2, and they also add quite a bit to the stability and rigidness of the frame itself, so they're really a structural part of the machine. I really highly recommend anybody who buys a Modix machine get the enclosure, because it really does make a difference. Alright, so we've got the top panel put on. This is basically just the top frame. Then I'm moving the bed so that it's sort of centered in the middle of the machine, so that way I can put that bottom panel on. Again, I mentioned earlier you have to take that front panel off a few times, so you can see it's sitting on top of the bed right now. And once I get that bottom panel on, I'll go ahead and put that front panel right there back on the machine, hopefully for the last time, and then we can move on getting the rest of the enclosure put on the machine. All right. So next we're going to put on the front, the sides of the front. So this is what the doors are eventually going to attach to. So it's just some black strips that kind of cover up the 40/40 extrusions on either side, kind of make it look nice, look a little bit more industrial too. So we've got that. Different day. So now we're moving on to the bigger parts of the machine. And this is where it's actually going to look a lot bigger. So right now it looks like a big machine. Don't get me wrong, but once we put these panels on that have the extended top on them, they're really going to start to look a lot bigger. So here's the first one, just the side panels. So interesting thing about how these panels are designed is that there are a few holes that are just holes, and so you need to put the T-nuts in the 40/40 frame first, and then try to line up the holes with those T-nuts. But it would be hard to do that on all of the holes. And so what they've done is they put little slots that will allow you to slide through a 40/40 T-nut into the frame and then move it into place with a screwdriver or tweezers or something like that. So you just put a few T-nuts on, attach the panels to the frame, and then put the rest of the T-nuts in and slide them behind the holes and then screw them on. It's really kind of a nice design to make putting these panels on a lot easier. Now this back panel is tricky because you can see sort of the fingers on the back side there. They slide in between the cables and behind the electronics box. So you have to actually remove the electronics box from the machine, slide the fingers through the cables, and then put the electronics box back on through the back of the machine. So that was a little bit tricky. The rest of it though, again, with the slots that you can slide those T-nuts into and then move them into place behind the holes, makes it relatively simple to get that in place. The challenge here is making sure that everything lines up on all four sides really, but the three sides, the two sides and then the back are really the most difficult, because the tops need to line up, the sides need to line up, so that the top frame, which is what I'm opening right now, the top frame, when we put that in place, all of the holes will line up where they're supposed to be in each one of the corners and each one of the sides. So basically, now that we've got the side panels on, we're going to build a frame for the top part of the machine. Now this is something that they changed a little bit in later batches of these V3 machines. The first batches came this way, where the sides and the back were all one full panel. But for shipping purposes and to make things a little bit more economical, they've actually started shipping the top section separately. So it's not one continuous panel anymore. So if yours looks a little different from this one, that would be why. Just for logistics purposes and cost purposes, they changed that design slightly. Okay, so there's these corner brackets that go and they kind of hold the 2020 profiles together. And so that's really how the majority of the top frame gets put together. A lot of these little corner pieces that just hold things together, quite honestly, is sort of mind-numbing. There's a lot of them, and it takes quite a while to get this frame put in place. But once you do, you start putting panels on it, it starts to feel like you're actually making something. So that's the step we're at here, where we're attaching that panel to it. Then of course, once we have that, we can take that frame that we've now built and apparently text somebody about it. And then we can put the feet on where it attaches to the top of the frame itself on the machine. Get this big spider looking thing moved over to the Big-60, drop it in, and you can see all the holes now line up where they're supposed to be. We can drop those T-nuts in through those slots and get everything put together there too. One thing I did not do properly here is you may have noticed that there was a circular hole in the top back section of the back panel. I failed to put the cover on that hole before I put the top on the enclosure. It's a significantly more challenging process to reach in and put the cover over that hole when you can't reach both sides of it, because it's basically just a screw and a nut that goes through the hole, and you can't hold the nut and also turn the screw at the same time if you can't reach your arms all the way around, which is pretty much impossible unless you're I don't know, Inspector Gadget or something. So that was a mistake I made. Don't make that mistake. Put the covers on before. Otherwise, if you actually get the active air filter, leave it off, and you can hook your air filter up to that hole in the back and then the holes on the side of the panels as well. Okay, so with the top on, it's now time to move on to the top pivoting door, the top section. So that's what I'm building right now. This is the frame that will be what actually pivots up and over the machine to give you access to get in and mess with stuff. In this case, we are putting acrylic panels on it because you do need to be able to see what's going on inside of the machine. Acrylic is not as good an insulator as the ACP is. It's also not as structurally strong as ACP is. But in this case, I'd much rather be able to see what's going on inside of my machine and sacrifice a little bit of that insulation and structural rigidity for this particular part. So that's what we're building here. You can see there it is. We've got it attached to the machine. It does in fact open and close, so success. Next part is we're going to move on to the doors. So the doors for these are again improved over V2. V2 it was basically just a sheet of acrylic with some hinges on one side and handles on the other. In this case, there's actually a frame for the door. So that's a much better way to do things. So here I'm putting together the frames, and then shortly I'll attach the acrylic onto the frame itself. And by doing that, we now have a much more rigid, much more, I don't know, more better frame for the doors themselves. So when you go to open and close them, they don't feel as flimsy as they did in version 2. Again, just a nice upgrade from V2 to V3. All right, here go the acrylic panels. There's one, and lots of nuts. There we go, and there we go. So we've got the door frames. Now we're doing the hinges, and oh, not quite. Okay, so now we are doing the lower and upper sections of the front frame. So in order to ensure that the doors are nice and rigid and they stay where they're supposed to be, yet you can also open and close them and have full access to the inside without a support brace in the middle, there are these support rails that go above and below the doors to kind of help add some structure to the opening of the machine itself. I did have to take the screen off in order to be able to access the screws for the top rail that goes in there. I keep calling it a rail. It's a 2040 extrusion that goes in the top and in the bottom, and that way I can put on the hinges and I can put on the doors, and everything will line up nicely. I say everything will line up nicely, but of course it's not as easy as that. So you'll see here that I have to. Yes, I have to go to great lengths to get these doors to attach. And then as I open and close them, as they swing them open and line them up with each other, they never line up quite perfectly. So you have to loosen and tighten the brackets that hold the corners together, and just kind of, finagle them a little bit so that everything lines up properly. Then you can tighten it down, and now you've got nice parallel doors that open and close without running into each other, without running into the frame. It does take a little bit of time, requires some patience, but stick with it, and you will get doors that line up nicely. Here I'm putting on the spool holders and the filament detection sensors. You can't really see me putting on the filament detection sensors, but that's what's going on over there, which is really one of the last steps to having a fully functioning 3D printer. So we are darn near finished building this machine, which means that we're going to start getting into things like testing and calibration for this machine. So here you can see I'm just putting some finishing touches on the handles, on the doors, getting everything fully lined up. There's a magnet that is the stop for the doors that holds it closed, and there we go. Yep, got the machine turned on. I'm starting to move the head around. Hey, look at that, it works. So move it back and forth a little bit. Okay, so we'll cut off some of this because I had an issue where actually let's not cut out some of this. Well, we can cut out a little bit, but all right, we'll talk about this. Okay, so here I am raising the bed. You can see I'm using that same 3D printed jig to get the Z offset set correctly, and also to get the BL touch put in its proper place. Moving the print head around, making sure that everything clears, everything's level, and then there are some scripts, some macros that run on the Duet itself, and by using those you basically can run back and forth through the tilt calibration, the Z offset calibration, things like that. Now I ran into an issue here, and one of the issues I ran into was the fact that if you remember that support rail that was in the back that has the drag chain attached to it, and I said I had to lower it a little bit. Well, when I did that, I didn't have it quite in the right place. Also, the drag chain connector, the bracket that actually attaches to the Y-axis system here that moves both on X and on Y, I had that bracket pushed out. It was angled toward the back, and it was actually scraping the back of the machine. And I talked to other customers who, in the early days of building these machines, were building theirs. They ran into the same problem. So it's something to be aware of. The drag chain in the back of the machine will tend to want to scrape on the back panel. So make sure that you account for that, you look for that, and it's not preventing movement along the X-axis like it did for this one. It took me a while to figure it out, but I finally did figure it out and got everything dialed in and calibrated as well. That is the end of the video, but here are some pictures of the fully assembled machine in its full working state. This was a machine, again, that I built for a customer and got it all dialed in and calibrated, got everything working properly, and then put it on the pallet, which you can see in the corner of the screen there, and got it all packaged up and secured so that it could be shipped via freight to the customer. So that is the Modix Big-60 V3 build process in time-lapse form. Hopefully everybody found that interesting and informative. It is a different build process than the V2 build process was. If you go back and you watch some of the V2 build videos, you can see the differences. In general, I would say this is a significant improvement in the build process, not just in the instructions, but also in the way things go together. You know, I particularly like the individual corner assemblies, where you assemble 4 individual corners, put it all together, and then the bed is what attaches each one of them to each other. So that's a pretty nice upgrade. The panels are a nice upgrade. The touchscreen's a nice upgrade. The Duet Wi-Fi controller, a 32-bit controller for this machine, is pretty nice. The improved high wind linear rails are very nice. The fact that we're using dual Titan Aero extruders and hot ends is very nice. So overall, I guess my summary would be it's a very nice upgrade over V2. All right, cool. Well, thank you very much for watching this time-lapse video. I hope you enjoyed it. Please do like and subscribe. Leave your comments down below. Any questions, shoot them over to EcoStruder@heartsmartproducts.com, and I'll get back to you. But until then, everybody go out, have fun printing, and we'll see you next time.